Hello there, Mr. Sutton here, bringing you the IM3 6-3 Extra Practice number 6 solutions on adding and subtracting rational expressions. There's a puzzle that goes with this, so let's see what that's all about. So here's the puzzle that goes with our extra practice problem set. In this one we have one of these did you hear about type puzzles. The idea here is that we solve all these different problems, and let's say that I solve A, for example, and I find the answer in one of these columns of answers. And actually, the A through E are going to be this left column. F through J, we're using this right column here. So I find the answer over here. Whatever word is next to that answer, I just put in the box with that letter up here. And if I put all the words in the correct order, it should have some witty thing that we heard about. So let's see what we're hearing about. So here we go with problem A, the first problem in our set. With all these problems, my strategy is going to be more or less the same. Do all the factoring I need to in the very beginning to see what the LCD is, find the LCD, the least common denominator, and then multiply each fraction by whatever it needs to get that LCD before I add them together. So in this case, there's no factoring or anything to do. I just have one denominator, this A, so that's going to be the LCD by default here. And now to get the common denominator, well, I don't need to do anything to the first fraction because it's already got it. The next one, though, we can think of this as a 2 over 1, and I would have to multiply that by A over A to get at the LCD. This is another strategy I'm going to keep using. I'm multiplying by something over itself, a fancy form of 1, a fufu, so that each time I'm multiplying, I'm not changing the value, I'm just changing how it looks. So going back now, we have 5 over A plus, this is going to be 2A over A. Since I have the same denominator, I can add these together. So I'll keep the denominator the same. It's an A. And then up here, 5 and 2A, those are not like terms. So I'll just have to leave this as 5 plus 2A or 2A plus 5. Either of those, whatever I need to match. And I see 2A plus 5 over A right here with the word the. So that goes in box A. There's no factoring to do at the beginning, so I'm just looking at denominators. The only one is the A plus 4, so that is my LCD. My first fraction then can stay the same. Second fraction, well, it's a fraction if I think of it as 3 over 1. I'll multiply that by A plus 4 over itself to give it at least the LCD in the denominator. First fraction, we can bring that down again. No changes needed yet. For the next one, let's multiply this out. So we have 3 times A and 3 times 4, so 3A plus 12, all over A plus 4. Now I can combine these into one big fraction over A plus 4. So the 3A is all by itself, no like terms there, but the 8 and the 12 can combine to give me 20, so 3A plus 20. And let me just double check to see if I can factor and reduce this at all. 3A and 20, there's no common factors there, so this is as good as it gets. And that's going to correspond with driving right there, that answer. So I'll put driving in B. For this one, no factoring to do in the beginning. My LCD, the only denominator, is going to be this 2A minus 3. This time around, the first term needs to be changed. If I think of this as a 4 over 1, then I would just multiply this by 2A minus 3 over itself. And then the second fraction, which already has this LCD, can stay the same. So multiplying this out in the first fraction, distributing the 4, we have a 8A minus 12, all over my LCD of 2A minus 3. Second fraction didn't need anything changed. Now that I have the same denominator, let me add these together. Keep my denominator of 2A minus 3. 8A plus 5A is 13A. And then the minus 12 is just along for the ride. There are no common factors between 13 and 12, so this is done. And I see this answer right down here. So this is the word teacher going in spot C. For this one, the only denominator is 3A minus 1, so that's our LCD by default. So that means my first fraction doesn't need to change. For the second fraction, I'm going to do a couple things. I want to write a plus minus 2 over 1, just so I have that negative taken care of. And I also want to multiply by 3A minus 1 over itself, because that's all this needs to get the LCD in the denominator. So keeping going here, First fraction doesn't change. Next fraction, we can distribute that negative 2 now. That's going to be a minus 6a plus 2 all over 3a minus 1. Combining like terms with this common denominator, negative 6a doesn't need to combine with anything. 7 plus 2 gives us 9. And now checking here, I can take out a negative 3 from both of these terms. So that leaves me with 2a minus 3. Now taking a look at my denominator, there's nothing that's going to cancel with this. So you might think, well, we just kind of wasted our time factoring when we didn't need to. The factoring didn't have a point, it was just kind of there. However, if we look over here with our answer choices, we see an answer choice right here with this negative 3 factored out. So they factored everything as much as they could, so that means we kind of have to as well, even if ultimately we can't cancel anything out. So we can put who in spot D. Next up, no factoring to do on this one, and only one denominator. So the LCD then is 5a plus 2. And that means the first fraction can stay the same. Second fraction, I'll make this a plus negative 6 over 1. And then to get this common denominator, we'll just multiply by 5a plus 2 over itself. First fraction, just bring that down, no changes. Next fraction, let's distribute this negative 6. So that's negative 30a minus 12, all over 5a plus 2. Combining like terms and keeping my denominator now, we have a plus negative 30a, that's negative 29a. Negative 9 plus negative 12 gives us negative 21. And other than taking out a negative 1, there's nothing I can really do to factor this numerator. So let me see if I can find this answer the way it's written. I do see it right here. That's the word decided going in box E. So we've moved on to problem F, which means we have a whole new set of answer choices to choose from. All of these have X's in them. This problem, though, starts off kind of the same as the other ones. We can try to factor, but there really isn't any factoring we can do, even though the expressions are a little more complex. So my LCD is just going to be this lone denominator of x squared plus 10. So we've got the first fraction staying the same. For the next one, we've got 4 over 1 times x squared plus 10 over itself. Bring down that first fraction, no changes. Next one, let's distribute that 4. So that's 4x squared plus 40 all over x squared plus 10. So let's combine these to have a single common denominator of x squared plus 10. And now we've got a 4x squared, 3x, that doesn't combine with anything either. The only thing that ends up combining is the 1 and the 40 for 41. Now this is the point where we might try to factor and see if we can simplify this a little bit more. I suspect I'm not going to be able to factor this though, since the only thing I could cancel it with would be an x squared plus 10. Let's see if I can find this the way it is in the answer choices. Right there. So I see everything I need unfactored, so I'm not going to bother trying it here. So let's put the word 2 in spot F. So for problem G, you might notice the intensity level has gone up a little bit. Now there are not 2, but 3 terms to deal with. And you might also have noticed we finally have a term, this x squared minus 9 denominator, that can be factored. So we're going to go ahead and do that. So everything else is going to stay the same for this first step, but down here we can square root and use the plus minus shortcut. So that's going to be x plus 3, the square root of 9, and x minus 3. Taking a look at our denominators, we definitely need x plus 3 and x minus 3 in the LCD. That also covers the x minus 3 in the second fraction, and then there was no denominator in the third fraction other than the invisible 1. So let's multiply these each by whatever they need to get the LCD. For the first one here, that can stay the way it is, no changes because it has the LCD. Next fraction, we need to multiply by x plus 3 over itself. That's the piece it was missing. And for this one, this is going to get multiplied by x plus 3, x minus 3 over itself. Okay, let's keep going now and simplify this. First fraction, no need to simplify anything there. Next fraction, we can distribute the 2, so that's going to be 2x plus 6 over the LCD. And the last fraction, we can FOIL this out here. We could distribute the 1, but what's the point, right? So we have x squared, And then we have, what else? We should have a minus 3x plus 3x minus 9, so just x squared minus 9, because those plus 3 and minus 3x's are going to cancel. You might have also noticed this was basically a plus b, a minus b, so a squared minus b squared is what we get out of that. I will write the denominator as I've been writing it before, though, without multiplying that out. No need to. So we end up now with a common denominator of x plus 3 over x minus 3. And then combining like terms, well, we have an x squared that can't get combined with anything. We have a 2x that also has no partners out there. We have a 5 and a 6, that's 11, plus another negative 9 is going to be 2. And just to double check, are there factors of 2 that add up to 2? Not so much. We have got 2 and 1, and that's about it. That adds up to 3 or negative 3, depending on your signs. So this is as factored as it's going to get. And luckily, I do see it right here with grade, so that's going in G, G for grade. We've got 3 terms again. Nothing needs to be factored, though, so let's go and see what our LCD is going to be. So we've got the x plus 2 from our first denominator. That makes it in there. Also the x minus 2, which is slightly different. And that looks like it for denominators. So now we need to figure out how to get everything to look like this in the denominator. So looking at our first term, that's missing the x minus 2. So let's multiply that by x minus 2 over itself. Next term, we're missing the x plus 2. So let's throw that in there. And for our last term, I'm going to do 2 things there. I'm going to make this a plus negative 5 over 1 so that I don't have to worry about the negative later on. And then I'm going to multiply this by, well, this is missing the entire LCD, so x plus 2, x minus 2. All right, let's simplify a little bit, and then we'll combine some fractions. So first fraction, we've got x being distributed to the x minus 2. So that's x squared minus 2x. And then we have the LCD, x plus 2, x minus 2 in the bottom. For the next fraction, this x gets distributed this time to x plus 2. So x squared plus 2x. And then LCD in the bottom. Now, for this last one, I'm going to do this in 2 steps. I would like to multiply the x plus 2 and x minus 2 together, and then I will distribute the negative 5 to it. So I'll do that first multiplication up here, just so I don't have to rewrite the entire fraction twice. So we've got basically a plus b, a minus b sort of situation. So I can just square the 2 things and stick a minus between them. So x squared and 4 with a minus there. And now I'm distributing negative 5 to x squared minus 4. So that's going to be negative 5x squared plus 20 with the LCD in the denominator. All right, let's put this all together. So we have our LCD of x plus 2, x minus 2 downstairs. And upstairs, let's combine like terms. We'll start with the x squareds. We have x squared plus x squared is 2x squared, plus a negative 5x squared is going to be a negative 3x squared. Next up, this negative 2x and positive 2x cancel out completely, and that's the only terms with x. So the only thing left then is just this positive 20, which comes along for the ride. Taking a quick look, it doesn't look like I can factor my numerator at all. So this is going to be it for this problem. I see that down here with the word on, so that's what my h is going to be, is on. For problem number I, we again have nothing that needs to be factored. So let's go straight to finding the LCD. We need an x minus 3 in there for this one, and also an x plus 5. And it looks like that's it. There's no other denominators out there. So let's start multiplying by some foo-foos to give everything the LCD. First fraction, we're missing the x plus 5 down there. So x plus 5 over itself is our multiplier for that one. For the next one, let me make this a plus minus 10 to start with here, over x plus 5, so I don't have to worry about the negative later on. And then we're missing an x minus 3 down there, so let's multiply by that over itself. And then finally, with this 2, that's missing the whole LCD, so let's multiply that by the whole LCD over itself. All right, let's simplify these now. So we've got our first fraction, 10 being distributed here, so that's 10x plus 50 with the LCD, x minus 3x plus 5 down there. Next fraction, we've got negative 10 being distributed to x minus 3, so negative 10x, and then negative times a negative is a positive 30, all of that over the LCD. And then finally this last one, I'm going to need to distribute the 2, but first I want to multiply these two binomials together, so it'll make my life a little easier. I'm going to do that up here where I have some room. So foiling this out, first gives us x squared, then we have 5x for the outers, inners is negative 3x, and last is negative 15. And then combining those two x's in the middle, we end up with x squared plus 2x minus 15. So this is the LCD just in another form. I'm going to distribute 2 to that now. So this is going to be 2x squared plus 4x minus 30. All of that over the LCD. Time to combine some like terms. So we have our LCD of x minus 3, x plus 5, one big fraction now over that. And then for the, I'll do the x squareds first. The only squared term is this 2x squared, so that's coming along for the ride. Now for the x's, I have a 10x and a minus 10x that are canceling. And then I have this 4x that's all by itself, so it's got to be a plus 4x there. For the constants, we have a 50, plus 30 is 80, minus 30 is back to 50, so plus 50. Now, this is the point at which I might check to see if I can factor my numerator, and I definitely can. I can take out a 2 from all this, but let me quick check up here to see if I actually do end up needing to factor anything to match one of the answers. So I actually see this whole expression right up here at the very top. So I'm actually just going to take that answer at face value and put a the here. Now, if you were curious if we actually could have broken this down a little bit more, if I took a 2 out of the numerator, that would leave me with x squared plus 2x plus 25, and then I'd be looking for factors of 25 that add up to 2, which there are none. So I actually couldn't go any further after taking out this 2, and I would not have been able to cancel out anything down here anyway. So anyway, it's time to move on to the next one. All right, here we are, final problem. This one has a little bit of a curveball at the end of the problem, but we'll address that when we get there. To start off with, nothing needs to be factored. Let me just get my LCD. We have an x minus 2 and an x minus 5. And now let's start multiplying by things that we need to get that LCD. My first term has a 1 in the denominator, so I need to multiply by this whole LCD over itself. And then for my next term, I'm going to make this a plus minus 2x over x minus 2 just to take care of the negative. And then that's missing the x minus 5. So let me multiply by x minus 5 over itself. And then my last term, let me make this a plus minus 5x over x minus 5. And then multiply by the x minus 2 over itself, because that's what I'm missing in that denominator. All right, time to start simplifying this a bit. Now this first one, I'm going to want to distribute this 3 at some point, but first I'm going to multiply this LCD out and put it in standard form just to make my life a little bit easier. And I'll do that all up here to save some room. So first gives me x squared, outers is negative 5x, inners negative 2x, and then last is going to be 10. Combining those x's there, we have x squared minus 7x plus 10. And now I have to actually distribute this 3 to what I just multiplied out here. So that's going to be 3x squared minus 3 times that is going to be 21x plus 3 times 10 is 30. All of that over my LCD of x minus 2, x minus 5. Next fraction, distributing the negative 2x, we have negative 2x squared plus 10x over the LCD. And then for this last one, we have negative 5x squared plus 10x, all over the LCD. Combining like terms, we have our common denominator of x minus 2, x minus 5. And for the x squareds now, we have 3x squared minus 2x squared, which is 1x squared. 1x squared minus another 5x squared is going to be a negative 4x squared. Next up, my x's. Negative 21x plus 10x is negative 11x. Negative 11x plus another 10x is negative 1x. And then finally this 30, there's nothing to combine with that. Okay, this looks like something, if I wanted to factor it, I would have to use the AC method. So just kind of thinking this through, if I multiply negative 4 and 30, that's negative 120. So I'd be looking for factors of negative 120 that add up to negative 1. The closest I could get to this would be like 10 and 12, but I could only get a negative 2 out of that. There's nothing better that's going to get me closer to that. So this actually turns out not to be factorable. So let's look for this in the answer choices. So taking a quick scan here, I'm not seeing any negative 4x squareds upstairs. Here's a positive 4x squared. Let me look for the denominator. Like, we started out with x minus 2 and x minus 5, so there's no way we end up with anything other than that in the final answer if this thing can't be factored. So scanning through here, we have x minus 2, x minus 5 right here with this word curve, and I don't see any more x minus 2, x minus 5s. So this must be the answer. And I actually looked this up on Wolfram Alpha and a couple of other places, and it turns out that this is as good as it gets. This is actually a typo on the puzzle. Shame on them. But this has to be our answer, curve, so we'll put that in there. So our final answer to the puzzle then is, did you hear about the driving teacher who decided to grade on the curve? Oh, because he's driving and he's curving the grades? Yeah. Okay. It's been fun. Till next time, Mr. Sutton signing off.